Assalamu alaikum. Hi guys. In our previous tutorial we have learned how to deal with series diode configuration. In this tutorial we will learn how to deal with parallel and series parallel diode configurations. So here we have this simple circuit in which there is 20 volt DC source connected in series with one silicon diode, and voltage drop across this silicon diode is VD1. And here there are two portions connected in parallel with this silicon diode, that is VD2 voltage drop across this silicon diode, and these two resistors connected in series with each other but parallel with this silicon diode. And here we also have R3, that is 5.6 k ohm resistor connected in series with this circuit. So here I have two loops. One is this loop 1 and second is this loop 2. The current flowing in this loop 1 or this is total current, that is IT, and the current flowing through this diode, silicon diode, is I1, and the current flowing through these resistors are I2. So here we will learn how to find out the circuit voltages or element currents. Before heading forward, it's compulsory to know that there is a silicon diode connected in parallel with this portion. As we know that the voltage across silicon diode is 0.7 volt. So here if it is necessary for this silicon diode to have 0.7 volt in case if we want to connect, or if we want to keep this diode in on state. So if this get 0.7 volt, it will restrict this whole portion on 0.7 volt. So keep in mind that by applying KVL we will take 0.7 volt voltage drop across this whole portion. So let's apply KVL on this circuit. According to KVL, sum of all voltage drop equal to 0, that is minus E plus VD1 plus VD2 plus V1 is equal to 0. Here this E is our voltage source, that is 20 volt, plus VD1 is voltage drop across this first silicon diode, that is 0.7, plus VD2, as we discussed earlier that VD2 is voltage drop across this silicon diode or this whole portion, that is 0.7 volt, plus V1. This V1 is our voltage drop across this 5.6 k ohm resistor, equal to 0. So by simplifying it a little bit, we have this V1 is equal to 18.6 volt. So it is the voltage drop across this R3 ohm resistor. So now by using this voltage V1, I will find this total current flowing in this loop 1, that is IT. According to Ohm's law, IT is equal to V divided by R. So here I have the voltage, that is 18.6 divided by R3, that is 5.6 k ohm. So I have IT is equal to 3.32 milliampere, that is total current flowing in this circuit or flowing in this loop. Similarly, if I want to find out this I1 that is flowing through this silicon diode, or I2 that is flowing through these resistors, I will apply Ohm's law. So if I want to find out this I2, that is current flowing through these resistors, I will apply Ohm's law, that is V over R. V is our 0.7 volt, and R, that is R equivalent of these two resistors, that is as both are in connected in series. So I will sum their resistances. So I have this I2 is equal to 0.212 milliampere. Now I have this total current and I2. So I can easily find out this I1, that is total current is equal to sum of these I1 and I2 currents. So if I want to find out this I1, so I will subtract this I2 from this total current, that is I1 is equal to I total minus I2. So I have I1 is equal to 3.108 milliampere. Thanks for watching our tutorial. Stay connected with us for more complex configurations of diode.